This conference will now be recorded.
Hello, everybody. Thank you for joining the Satellite Book Club seminar series. This is session number 96. Thank you for joining us. Today's presentation, JPSS applications, datasets, training resources, and user feedback with our JPSS satellite liaison from CIRA, Jarell Torres, and Christopher White, the applications integration meteorologist at the Weather Forecast Office in Huntsville, will be our facilitator. Just a few reminders before we get started that this session, as you just heard, is being recorded. There will be an opportunity for Q&A after the presentation, and there we're particularly looking for questions from our forecast offices and regional headquarters. I'd also like to remind you, if you haven't signed in using your full name, first and last name, or perhaps you're using an office account, please note your name when asking the question so that if we need to follow up with you subsequently, we can easily reach out. We're always looking for future presenters as we head toward the 100th Satellite Book Club in early June. So if you'd like to be part of this seminar series, we would love to have you. Again, particularly if you have an application and you are at a field office. The training team can help create training materials that may be unavailable. Jarell's going to talk a little bit about training today, but if you have more questions beyond JPSS, Brian Mott at the Office of the Chief Learning Officer can help with that. I'd like to thank our Tower S team. We've got David Blutis, Lee Byerly behind the scenes. Kashad Bowman's off this week. The Office of the Chief Learning Officer, GOZAR, and JPSS program for their support. Of course, thanks again to our presenter and our facilitator. Without further ado, I'd like to introduce Jarell Torres, who, as I mentioned, liaisons between the National Weather Service user community and the research community, focusing on JPSS products, applications, and satellite training development for users. In his spare time, Jarell loves to storm chase, travel, hike 14ers, and CrossFit. So we're really glad to have Jarell back at the book club and looking forward to hearing about JPSS, particularly with the JPSS-II launch later this year. Jarell, take it away.
All right, thanks, Jordan. Can you guys see the screen and everything? Does everything look good?
We got it.
All right, well, let's get started here. So as Jordan mentioned, we'll be focusing on these JPSS applications, so we'll get right into it. Quick outline. This presentation will focus on several aspects of JPSS. I'll give a quick JPSS overview. I'll highlight a variety of JPSS applications. I'll also express how JPSS complements our geostationary data sets. And then I'll also, very importantly, show users how they can access the data online and in the AWIPS system for our NWS users. And then also highlight the satellite training materials and resources that we've developed for our NWS user community in regards to JPSS satellite datasets. And then also I'll post some questions for our users that are attending this session today and to collect more user feedback on the current existing JPSS datasets. So a quick JPSS overview. We're focusing on the Joint Polar Satellite System. It helps improve weather forecasting via simulation of observations into NWP models, provides global coverage over the oceans and data sparse regions, and also provides observational value and complement to geostationary satellites. Currently with JPSS, it consists of 5 satellites. Currently in orbit right now, producing datasets for our users are the Suomi-National Polar Orbiting Partnership, or SNPP, and then also JPSS-I, or what we know as NOAA-20. Now we're looking forward to the launch later this year of JPSS-II, which will be known as NOAA-21 once it becomes operational, which will provide additional datasets for our users. And then additionally, in the queue, we have JPSS-III and IV to look forward to within the next decade. Now, these satellites exhibit analogous instrumentation on board. Now, 3 of the 5 instruments that we'll be speaking about today will be about the VIIRS instrument and also the ATMS and CRIS instruments that provide temperature and moisture profiles that can be integrated into NWP and or into the blended products. And some additional information just to help with users that are unfamiliar. We'll focus on some of the JPSS imagery and dataset availability for our users, specifically the temporal resolution and data latency. In regards to temporal resolution, especially for our CONUS users in the lower 48, you're going to be getting datasets from SNPP and NOAA-20 in your AWIPS system. So you're essentially going to get at least 2 overpasses per day per polar orbiting satellites. Now, during the daytime, you'll be getting passes from SNPP and NOAA 20, roughly between 16 to 22Z, going from east to west, as this animation shows in the top right of the VIIRS day cloud phase distinction RGB. Now, for nighttime, overnight observations, you'll be getting data sets approximately around 5 or 6Z to about 12Z from east to west. And this highlights in the top right there, highlights the NCC product, or the product of the day-night band animation there, just of the SWATs over the lower 48s. Now, of course, for our Alaska users, they're going to get more frequent overpasses in the northern high latitudes and near the poles. And here's just an example in the top right, utilizing the Sierra Slider interface and utilizing I believe the I5 imagery band data sets. Now, of course, with SNPP and NOAA 20, their orbital swaths are separated by about 50 minutes or so. Now, in regards to data latency for NWS users in AWIPS via the satellite broadcast network, it's about an hour to hour and a half data latency, and with the direct broadcast, your latency is significantly reduced to approximately 30 minutes or so. And just for users that may be unaware, that data latency is essentially the time between the satellite overpass to when that data set is available in your AWIPS system. Next, here's just a slide highlighting some of the JPSS products, program products from the various instruments there, and then also the extensive list of applications as well, which I'll transition quickly into more of the imagery applications. And of course, these data sets are either accessible in your AWIPS-II and or online for users. So now, as we transition into some of those imagery applications, I'll start with some of the nighttime visible applications. You have the VIIRS near constant contrast product that's available in AWIPS. That is a derived product of the day-night band. And essentially, this product illuminates atmospheric features via reflected moonlight and also senses emitted lights at high spatial resolution. Here's just a few examples of some of those nighttime visible applications, and of being able to observe, say, low-level stratus and fog over the San Joaquin Valley, and then also the cloud cover offshore, being able to observe snow cover over the Sierras, and then be able to observe emitted lights from cities and or towns. Some additional applications, I know another challenge, especially from the satellite point of view, is trying to observe fire smoke at night. Here's an example of the Dixie fire. You're able to see the array of emitted lights produced from the fire, but then very importantly, being able to observe the fire smoke at night as well. In addition to this, you can also observe snow aerial extents. This is a more recent example back in April of some of the snow being observed from the NCC over the Dakotas and then also in western Iowa. And note also you can observe not only emitted lights from towns and or cities, but also from gas flares. As we know, in western North Dakota, it's quite known for their oil and gas industry out there. And you can see the emitted lights from those gas flares as well. In addition to this, so you have some other additional, like say, fire monitoring applications. I'll highlight the VIIRS Active Fire product here. This particular product can detect active fires during the day or night. It has three main display outputs there of observing your fire location, but then have your fire radiative power, FRP values, and fire detection confidence from 0 to 100%. In AWIPS, the imagery has been updated to define spatial resolution of 375 meters via the I-band data sets there. And here's just a more recent example within this, earlier this week, of the fires out there in north central New Mexico, specifically the Calf Canyon Hermit Peak fire, observing the VIIRS Active Fire data sets and pixels there. Now, these pixels are color-coded from yellow to orange to red to dark red. The more red or dark red the pixels, the more intense the fire is, and the higher the fire intensity values, which are expressed quantitatively via megawatts are the values there. And in addition to this, here's just one example of utilizing just the individual spectral band of the 3.7 I4 band there at 375 meters, being able to observe your fire hotspots seen by the warm brightness temperatures. This kind of outlines your fire perimeter. And the more active areas of the fire, and this is of the Boot Lake fire in Oregon last year. Some other fire monitoring applications to highlight as well are the VIIRS fire RGBs, and this is how they look in the AWIPS system. You have your VIIRS dayland cloud fire RGB, but then you also have your VIIRS fire temperature RGB. Now here's an animation over a course of a few weeks in late July of last year of the Dixie fire. And with the VIIRS dayland cloud fire RGB, it is sensitive to fire smoke and vegetation health. Where with fire smoke, you can see in the bluish gray, the smoke that's being engulfed in central and eastern California there. And then also note with this RGB, it's also sensitive to vegetation health. So you can observe like burn scars. So you can see some of those burn scars from other fires that occurred in the southern portion of the scene and the southeastern portion of the scene, which when you can observe burn scars, that could be helpful for future hydrological or flash flooding applications. Aside from the dayland cloud fire RGB, focusing a little bit more on the VIIRS fire temperature RGB, it can be utilized in a qualitative manner to infer your fire intensity. Now your pixels will range from red to orange to yellow to white. Red pixels indicate cooler fires, and yellow and white pixels indicate the most intense fires. So within this animation over the course of a few weeks, you can see where it's very intense on the northern and also the southern and southeastern periphery of the Dixie fire there, and as it moves in aerial extent to the north and to the east. And here's a more recent example of the Calf Canyon and the Hermit's Peak fire earlier this week of these RGBs. You know, you can see the extensive smoke that's being produced to the southeast of those fires. You can see some of the older burn scars being observed in the brownish red, and then the more active or the newer active fires on the southern and northern peripheries of that fire there. And you can also tell the how intense those fires are with the VIIRS fire temperature RGB there as well. In addition, we have our blended products. A few of the notes here: you have your vectored layer precipitable water product, 16-kilometer resolution, hourly data. This particular product demarcates precipitable water values into 4 atmospheric layers. This is an animation of Hurricane Ida as it moved through the Gulf of Mexico, made landfall, and moved inland. So you have 4 layers. You have the surface to 850 millibar layer here in the top left, 850 to 700 in the top right, 700 to 500 in the bottom left, and 500 to 300 in the bottom right there. And you can see how the precipitable water values change from one thickness layer to another. And you can see how much precipitable water is being observed in even the highest of levels of the 500 to 300 millibar layer of Hurricane Ida as it made landfall there. In addition, you also have your global blended products as well, with your blended TPW, your percent of normal TPW, and then also your rain rate products as well. And here's just an example of the, I think Hurricane Larry, I think it was, as it was moving towards Bermuda at this particular timestamp back in September of last year. Additionally, we have satellite-derived sounding capabilities. You may have heard of NUCAPs. Essentially our temperature and moisture retrievals derived from CRIS and ATMS instruments. Now in your AWIPS system, you're going to get swaths of data of soundings in pretty much data quality soundings that are reflected in green, yellow, or red, and they range from good to bad data quality soundings, but the good soundings are in green. And here's just an example of a fire in South Texas earlier this year, in late March actually, of the Borrega fire in South Texas. And what you're doing here is overlaying your NUCAPS data sets over your RGB imagery, clicking on that sounding, and this is what the sounding looks like in the AWIPS system there. You get an idea of your atmospheric temperature and also your moisture profiles with height there. And these NUCAP soundings are quite useful, especially in data sparse regions in the western CONUS, and also where your radar observations are poor or limited. And then also I wanted to highlight the gridded NUCAPS capability as well, highlighting the same event here with the Borrega fire, or the relative location of where the star is. And this is utilizing the gridded NUCAPS total precipitable water product in the plan view, and you can observe based on the values here of the lower precipitable water values that are being observed near this fire. Also, we have our HER smoke model data sets available for user consumption. I know this is a fan favorite from WFOs, especially highlighting and messaging to the general public via social media, whether it be in regards to highlighting the smoke impacts over their particular CWA, or in messaging of the human health aspects as well. And with the HER smoke, it's at 3 kilometer spatial resolution, provides hourly updates. It has a 48-hour forecast lead time at 0, 6, 12, and 18 UTC. And then at other times of the day, it's only an 18-hour forecast lead time. But essentially with the HER smoke, it simulates the fire smoke emissions, plume rise, and smoke distribution. It's initialized by the VIIRS and MODIS FRP data sets. And here's an example of earlier this week. The model was initialized at 12Z on the 2nd of May, and it's forecasted out to 48 hours of the fires out there in north central New Mexico. And over the course of 48 hours, how the smoke distribution is moved off into the Oklahoma and Texas panhandles there via the near surface smoke product on the left and the vertically integrated smoke product on the right. And here's also just a comparison as well at a particular timestamp with the HER smoke on the left, near surface smoke. It's the same initial model or same 12Z initialized, and it's forecasted out to 16Z on the 2nd of May. And what I did was compare it to what I observed in the GO16 geocolor. And what's interesting is that the HER smoke suggested at this particular timestamp at 16Z, pretty much smoke moving into the Oklahoma and Texas panhandles there, a kind of a curvy feature there in the HER smoke, but then that also was visually seen via the ghost geocolor. So I thought that was really interesting to point out. And in addition to that, unfortunately, this is not in relation to the case event I just highlighted, but from a different case event. But this is the highlight to users that there's also a vertical cross-section capability with the HER smoke concentrations, the smoke concentration with height, and then also over complex terrain. This case event is highlighting the smoke concentrations with height from the Cameron Peak wildfire and also the East Troublesome wildfires back in 2020. And then some additional data sets for our users. These are just select ones. I won't be able to cover everything, but top left here is your VIIRS snowmelt RGB, and where users can be able to infer in a qualitative manner areas of wet snow and dry snow for hydrological applications. Top right, you have the VIIRS dayland cloud RGB that can also observe dust, and this was a big dust storm from a strong low pressure system that moved off the central Rockies, moving into the central plains, providing strong winds and significant dust in Colorado, Kansas, and the Oklahoma and Texas panhandles there. Bottom left here, we have an animation of the liquid equivalent snowfall rate products, which not only incorporate data sets from NOAA 20 and SNPP, but also from MATTOP-A and MATTOP-B, and then also DMSP as well, and a few other satellites as well. In the bottom middle, you have the VIIRS day cloud phase distinction RGB. Can be utilized for lake ice monitoring over Lake Erie. But then also, this was an interesting event where you had a ship breaking through the lake ice. And if you look within the white ellipse there, from one pass to another, separated by 50 minutes, you can see the breakage in ice going to the southwest there. And also, in addition to lake ice monitoring capabilities, we also have sea ice monitoring capabilities. Here's just one example from the VIIRS, I believe, snow cloud layers product out there in the Bering Sea, west of Alaska. And you can see the sea ice and sea ice motion over the course of a few days. And then some additional data sets as well. Another RGB observing the landfall of Hurricane Ida. Also in the bottom left, utilizing the nighttime visible applications to observe areas or to infer areas that are experiencing power outages with the nighttime visible applications. So what you'll see with power outages with the nighttime visible applications is that you'll see a significant reduction in the emitted city lights, and you see some of those impacts in southern Mississippi and southeastern Louisiana and along the Gulf Coast as well. from a day or two after Ida made landfall. And one last Ida reference as well is the VIIRS flood product that observes a day or two after Hurricane Ida passed through and the subsequent flooding and or inundation that occurs as well. Now, I have a few other examples here from non-AWIPS in addition to that, and the top middle here is the VIIRS land surface temperature product, and this is via the JSTAR Mapper website. Top right is the sea surface temperatures via Real Earth, and then the bottom right here is your aerosol optical depth products from VIIRS, and this is from the Aerosol Watch website, where it's observing some of the smoke emissions from the fires out there in New Mexico. Now, I know I highlighted a variety of JPSS applications, but I also wanted to highlight to users just with all the data sets that are coming in from JPSS and GOES. You know, you have SNPP and NOAA 20. Later this year, we're looking forward to NOAA 21. And then from the GOES perspective, we have GOES 16, GOES 17, and then we're looking forward to GOES 18 here soon as well. But the point is, with this slide here, is to be able to utilize both data sets in operations for the operational mission. And in this particular case, just highlighting an example for the fire mission. So here's an example of the Cooks Peak fire in New Mexico back in April. And pretty much from left to right, the left animation here highlights your VIIRS fire temperature RGB as the data sets are coming in from SNPP and NOAA 20, 50 minutes apart, and you're being able to observe the fire in the fire perimeter and how intense those fires are too in the northern periphery at high spatial resolution of 750 meters. You're also observing some pyroQ that are being produced from the northern periphery of that fire as well. But then how you compare that to GOES, here's just an example roughly around the same time here. So of course with GOES, you have that high temporal refresh rate, which the animation on the furthest right shows, where you have a cadence of either every 1 minute with the mesosector, every 5 minutes with the CONUS sector. But what you can do is utilize both data sets to observe the fire. And with the GOES data sets, you have that finer temporal resolution. But with the GOES RGB, it's only at 2 kilometers. This is where the VIIRS data sets come in. When they do come in your AWIPS system, you can get a better idea of the fire extent, and with this RGB, the fire intensity, and you can utilize that data set, those data sets once they come in. And of course, we know with the VIIRS data sets, they're not as timely as GOES, and that's where with the high temporal refresh rate you see in the right animation there, you can observe that fire behavior in a shorter amount of time. But the point is, you can utilize both data sets together to assist in the operational fire mission in this particular case. Now, I mentioned a lot of applications, and I also wanted to highlight, very importantly to users, how can users access the data? So here's just a few general examples about how you can access the JPSS data in AWIPS. Pretty much all you gotta do is go to the satellite tab, scroll down to SNPP and NOAA 20, and then you should be able to get an assortment of VIIRS data, NuCAPS, derived products, and gridded NuCAPS data sets. Also, there's blended products as well that you can access via satellite tab, scrolling down to the polar derived product imagery and going to your global blended products as well, whether it be the TPW, percent of normal TPW, and blended rain rate products. And note that I didn't get a chance to get a screenshot of the direct broadcast of how that looks in direct broadcast, but it should be relatively similar as well. And that's from the AWIPS perspective, but here's the near real-time imagery online. Here's just some select websites there that users can go check out, ranging from NOAA NESDIS, the Sierra Polar Slider, from SIMS VIIRS Imagery Viewer or Real Earth, the JSTAR Mapper web links, GINA's websites. Also, I worked with developing a web page and maintaining a web page that has a nice collection of near real-time websites that users can go check out, whether it be just VIIRS imagery, satellite-derived sounding links, fire applications, hydro applications, or connection to direct broadcast data sets. So you can check those out there. And then here's just a quick example. If you're on the Sierra slider interface, and if I click the video here, if you're on the web page interface, you can, and if you go under satellite, go to JPSS and you click on product. This is one way you can go check out all the individual bands, 22 spectral bands at high spatial resolution. Then you can also go check out some of your multispectral imagery with geocolor, split window difference, your RGB composites as well. Some I've highlighted today. And then some I did not highlight with your cloud products from CloudRx, and also your NewCap's Cold Air Aloft product. So, but this is just one way, going through one interface to help users go through the steps of being able to access some of this near real-time data. And in addition to this, we also have some satellite training materials that we have developed for users. Essentially, any data sets, or well, let me take a step back. The general rule of thumb is that for any data sets that are in AWIPS or that will be in AWIPS, we usually want to develop satellite training materials for our users so that they can have a better understanding of how to use the product and also be comfortable with utilizing the product in operations. And here's just an example of some of the quick guides that we've developed. There's also a lot for GOs as well. And these quick guides essentially highlight whether it be an individual spectral channel, products, RGBs, pretty much highlights to users, what is this data set, what is the algorithm makeup or RGB recipe, what are its attributes or spatial resolutions, spatial, temporal resolutions, data latencies, primary applications, limitations, imagery interpretation, and also some additional resources as well. In addition to quick guides, we also have quick briefs, which are product application videos, and also our satellite foundational course for JPSS. And then we also offer teletraining to our users weekly. They're also updated every month. You have myself that offers them. You also have Scott Lindstrom from SIMS, Dan Bikos from Sura, and Ed Soak as well. And that offer a variety of satellite training, whether it be from the GOES or the JPSS perspectives, and how you can utilize satellite data sets and become more comfortable with those data sets in operations. And there's a few additional links as well there for users. And as I come to a close, I know that was a lot of information in a short amount of time, but it'll be really interesting to see just whatever users that have attended the session today, just to get more of the user feedback, especially from the JPSS point of view. As I mentioned before, we have SNPP, we have NOAA 20, and we soon will get NOAA 21. And what you can do is either type it into the chat, or as we go into the discussion time frame, it'd be really interesting to get your feedback on, how familiar you are with these data sets. What data sets do you use in operations currently? How do you use the data? The frequency of the usage of the data? How do you access the data? Whether it be via AWIPS strictly or AWIPS and online, or if it's strictly direct broadcast. And another question I also pose that we can extrapolate on later is, if you're an IMET, for example, I've known that, as of, I think of at least last year's fire season, I know more IMETs have been utilizing the cloud AWIPS system, and it'd be really interesting to get their feedback as well, if they're able to access JPSS data via cloud AWIPS, and if so, which ones? And then lastly, something that we can talk about too is if there's any data sets that I've highlighted today that you're interested in and that are currently in your AWIPS system, you can connect with me and we can get you the data sets in AWIPS, whether it be, like, for example, the ALPW product, snowfall rates, the RGBs, and or the Beers Flood Aerial Extent product, for example. And but with that, as I come to a close, we're looking forward to JPSS-II here in the fall. That will provide more data sets for our users. And there's my contact information there on the left, and also my Twitter handle there. And I will end with JPSS on social media from our users, highlighting a variety of different JPSS data sets, whether it be Beers day-night band, blended products, and then also ending with some of the fire smoke. And with that, I thank you for your time and ready for questions.
Okay, thanks very much, Jarrell. That was a very comprehensive presentation. Lots of great information in there. lot of data sets and applications mentioned. I will just note that I did put a something there in the chat, like, feel free to respond there or just live if you want. You can verbally ask a question. Doing those questions, and Darrell, maybe it's a good idea just to put maybe those questions back on there here in a moment. But
Yeah.
So let me get started. So if y'all can continue with the presentation here, or the go-to meeting. We would like to encourage any of you to stay on for any discussion here as you're able. I know there's some severe weather going on right now across, especially it looks like the Southern Plains, but anybody else, we encourage you to stay on, especially from the field forecast offices, WFOs, and regional headquarters, but anyone as well, maybe national headquarters or research entities. And also, if you would just please specify your name when asking the question. Also, as noted here, if you need assistance with configuration of satellite products, the TowerS team is available to help, so you can reach out to John Evans and Lee Byerly for any support, and their emails are listed there. And then also contact Kashad Bowman on the TowerS team for any comments or questions just about the SBC in general. And did you know that TowerS actually has an NWS chat room? Yes, they do. It's listed there at the bottom, and they can be reached at Tower-S, so that's TOWR-S. So let's go ahead and get started. Let me go to the questions here. Let's see if we've got anything posted. So it looks like we've got a couple of things here. Well, oh yeah, also Lee Byerly does mention, please share any feedback you have on this session or the SBC in a short survey that's linked there. You'll see that in the chat. And then Bill Schoberg has a question. We can just maybe start with that one here real quick. It says, Jarrell, you might mention the Proving Ground Risk Reduction initiatives as a great place for NWS collaboration with developers to improve the operational use of JPSS data and products. So I guess that's a little bit more of a comment. Do you have anything just to say back about that?
Oh yeah, just we have a wide variety of JPSS initiatives, as Bill mentioned. We have Fire and Smoke Initiative, we have NewCaps or Sounding Initiative, we have River and Ice, we have a training initiative as well, where we kind of collaborate between the satellite trainers in development of satellite training, identifying training gaps. But as Bill mentioned, we utilize these initiatives to help our developers and improve our operational use of these data sets, or if they're developing new data sets that we want to get into AWIPS as well. So, but there's a lot of them out there, and that also consist of not only product developers, but then also a lot of our NWS users as well.
All right, thank you. Jarrell, I know, yeah, a lot of your, and thanks for putting the slide back up here, the request for user feedback. So, yeah, as I work with a research entity too, and feedback is of paramount importance in the whole O2R process, because without that, we don't know what's working or what's not working or what needs to be modified or changed. So, is there any sort of specific, yeah, there's things like HWT, there's OPG testing of products, there's other venues where, feedback is, kind of sought and corralled, via these specific kind of vehicles. But is there any other way that you generally get feedback or would like to? I mean, this is a nice venue to get that if anybody has any feedback they want to provide here. But people just free to email you and that kind of thing.
Yeah. So as you mentioned, like, email correspondence is really good. Over the years, I've been doing this for almost 6.5 years now, and email correspondence, of course, with our users. Also, you have our occasional conferences that we get to get more exposure to our NWS user base, but then also our non-NOAA users as well, and seeing what data sets they utilize and for what. And then also in forums such as the satellite, the SBC seminars here, other types of webinars, the FDTD satellite application webinars as well, where what I try to do sometimes, if a user is highlighting a particular products or different applications, such as, like, say, for fires, I'll reconnect with them as well to be like, oh, did you think about these data sets, or are you aware of these data sets to help with observing fire intensity or observing nighttime fire smoke, for example. So so I do utilize these seminars and webinars as a good a forum to exchange information and get latest feedback from that. And then also what I do too is I offer teletraining to users, and sometimes it's a hit and miss. It just depends on like I won't have weekly teletraining for users. I'll offer it, but we should have to wait for NWS signups to attend it. But I do get feedback from that interface as well.
Yeah, right. Yeah, I would encourage anybody to go to one of those visit teletraining sessions. And yeah, you can get just, sometimes you might be the only person on there, but that's okay. You can get a lot of one-on-one time. And I attended one of those just myself earlier this year, Dan Bykos. It was on satellite imagery used for mesoanalysis, and we had a lot of time to just discuss some things. So yeah, those can be great venues there. Yeah, I will say that, maybe if people are, if they have conference talks coming up, if they want to forward you some information about those or share what they're thinking about those, maybe you have time for discussion with them, whether using JPSS data, whether it be new caps or, whatever. I see new caps quite a bit. But any of these others, I know you attend conferences, you attended when I've given talks, and you and I have had chats afterwards. You would be very nice and have a question and come up to me and talk to me afterwards. So yeah, conferences are also good ways.
Yeah, and in reference to the teletraining, like it's also interesting too, because I'll get a wide variety of users. I'll get like new NWS meteorologists, and then I'll get people that have been in operations for 20 plus years. So it's a wide range.
Right.
Or a user that just changed offices from, say, a non-fire prone WFO CWA to like the Western CONUS kind of thing. So like, and then I also I have within the past few months gotten more IMETs as well.
Yeah.
Yeah.
No, go ahead. Yeah. Well, I was gonna say, yeah, speaking of IMETs, you did have that question in there. You were curious about especially IMETs and access to JPSS data sets via the AWIPS cloud. Just curious if there are any IMETs in attendance that happen to be in attendance here. You could provide some information about that. Even if it's just a comment, that's fine. You can put it in the chat room. But otherwise, you can always email Jarrell about that. And it's just Jarrell.Torres, T-O-R, just like your name, at NOAA.gov. So
yeah, it'll be really interesting from the cloud AWIPS point of view, because it seems like that's going to be the next thing where users will be utilizing most often. And whether it be in IMETs or any kind of meteorologist that's out in the field, and that they'll access that. So it'll be really interesting to see what JPSS data sets are in there, and also with the GOES data sets as well, and how we can expand on that in the future, especially with GOES 18 and then NOAA 21 coming on board here within the year.
Right. Yeah, I will say I really like how you demonstrated in the presentation the use of both GOES and JPSS in combination with each other. That can be very important because, yes, especially people in the CONUS, you really want, because of, time scales, the weather, takes place, you want something with a higher temporal refresh rate. So, 1 minute or 5 minutes is great. But then again, you can get some more information when they're available. The spectral resolution, with the JPSS, it's just higher spectral and spatial resolution. So there's a little bit more information to be had there. And so, yeah, using those in combination, I think, is always a good idea. You did also mention the advected layer precipitable water product, which is something that does not regularly flow in through AWIPS. So do you want to mention how people can get access to that?
Yeah, they can connect with me, and I'll connect them with our folks here at Sierra, and we can get you the AWIPS instructions to get those data sets. I know just a select number of WFOs have access to that at the moment, I believe via LDM. But also note that I believe this product will become operational sometime next year, 2023. But if they want it now, they can connect with me, and we can move forward with that. And
Okay.
that's not only for ALPW, you have the snowfall rate there data set as well. And
Right.
with the VIIRS flood product, I believe there's plans to get that into AWIPS. I think it's this year, but I'll have to recheck with Will Straka. I'm not for sure if he's on the line, but I believe that's soon to be operational, I believe.
Okay. All right.
It's undergoing testing.
What was that,
I'm sorry,
Straka?
go ahead.
It's still undergoing testing. There's some processing things on NDE that are being worked out.
Okay, so still being worked on. Okay.
But yeah, we do have several NWS champions, including Carl Jones. I want to give a shout out to him up at Grand Forks. I know he's really busy right now with the Red River, but we have several champions there that are willing to start looking at that once we get a more routine feed to look at. So.
Did you have a timeline on that, Will?
No, we don't have a timeline on that.
Okay, fair enough. Thanks for the update.
Yeah, so is that something that people can pull in through LDM or something right now, or? So
currently the direct stuff coming from the direct broadcast site and being run routinely at SIMS can be. We have instructions on our on the flood website to do that. I know that like I said, Grand Forks has pulled it into their system. I think Corpus Christi as well, and I think Southeast RFC have done that. So there's been a few people that it's very easy. The instructions are there on how to pull in both the VIIRS flood products and the ABI flood products into the AWIPS systems.
Okay. All right.
I will point you to. I know it's shameless self-promotion not self-promotion, the same shameless promotion for Grand Forks. They had a very nice social media post a few days ago. Showing the flood product up on the with the Red River flooding going on. So
okay, well, I'll have to check that out. So
yeah, there you go. Yeah, not everything is an AWIPS. I mean, everybody knows that. You go to the menu, and right now there's a bunch of placeholders for things. But Jarrell also pointed out just for example, the CIRA slider, which is a really nice little tool to have. And I think you can just Google CIRA, CRRA slider. And you can have access to that. There's a little archive of imagery there. I've used it, myself at my own office for, some training. But I just want to mention that as well until we can get some of these data sets flowing through AWIPS. Well, I guess, is there any other questions out there or comments even? I'm not seeing anything right now. Jarrell, any last minute things you want to add? Looks like we're getting close to our cutoff recording time, but any last things you want to add?
Yeah, as I mentioned, we look forward to JPSS-II here in the incoming months. But then also, if you didn't want to mention in the chat right now, you can email me directly, and we can get you data sets. Or if you just have user feedback, that's always appreciated as well. And we'll look forward to NOAA 21 here, and then also GOES 18. So.
Yeah, that's right. Yeah, it's going to be really interesting when we get 21 up there also, and then we'll have a little bit more continuity, with that, see a little bit of the evolution of the atmosphere over time with JPSS. So that'll be interesting. I'm certainly looking forward to that also in NewCaps. So anyway, I did also want to mention here before we go, the next SBC session is planned for next Thursday, May 12th. However, the topic is to be announced. So currently we don't have a speaker for that. So I mentioned to Lee that I would send a shout out. Anybody has something of interest they would like to present, please reach out to the TowerS team. It could be any of those folks that you see listed right there about a possibility for a presentation next week. So I think with that, I guess we're done in the interest of time here. And so I will now pass this back to Lee Byerly for any final remarks. And I want to say before I part, thanks again for all your work, Jarrell. Super nice guy as well. It wasn't mentioned in his intro, one of the nicest guys out there. And it's always fun to interact and speak with you, and especially when I see you at conferences and stuff. So you're always helpful and informative. So anyway, I'll turn it back over to Lee here.
Thank you, Chris. And hey, Jarrell, thank you so much on behalf of the whole group here for taking the time, for fostering this collaboration and providing this presentation to us. As Chris said, comprehensive. And gosh, I think this is your third time at the SBC. So thank you so much for your time. And likewise to Chris for being there as our host today, and for also being a several repeat presenter here at the SBC. Thank you all so much for a great discussion that I know I really got a lot out of. And of course, as the slide shows, please reach out to us if you have any questions or if anything we can help with regarding the Satellite Book Club and the configuration of satellite products. And I hope you have a great day. We'll end our meeting now. Thanks.